All right, so for heating and air conditioning, that's probably one of the topics that you're going to struggle with the most, just because every building is just a little bit different in terms of how it's heated and cooled. And most of the buildings, with the exception of Corbin and Olson and Grody Hall, which have 4-pipe systems, the other buildings have 2-pipe systems. What that means, without being a mechanical engineer, is that you simply can't kick the heat on and the air off, or vice versa, all in one shot, like you would at home with a central air unit. So because of that, we have to make decisions kind of based on long-term and short-term forecasts. We have a couple of different parameters. They're not set in stone, but they are guidelines to help us make sure that we're making the right call, that the trades are being used to the best of their abilities, and we turn over the buildings at the right time, because the last thing we want to do is turn a building over when it's too hot or too cold, and then we can't go backwards. So we use to turn on the air conditioner, which typically is the one that we most catch the most flack over. It's 3 days of 80 degrees or higher, with the nighttime temperatures not dropping below 50. Again, that varies between day to day and kind of that long-term forecast. We might have 4 days of 80-degree weather followed by 6 days of 50 or 60-degree weather. And in that case, we probably wouldn't turn on the air conditioning. Vice versa, we might have a few days that's 50 degrees, and then all of a sudden have 2 or 3 days that are 80 degrees, and the long-term forecast going up from there. In that case, we probably would turn on the air conditioner. The other piece we want to do is we want to save the equipment, because the last thing we want to do is wreck the equipment, because it's very expensive, very hard to get parts, and they're not readily available. So because of that, we have to make sure those decisions are made at the right time, because we don't want to turn on the air conditioner in a building and then it get too cold outside where it freezes the equipment and breaks it. So with that being said, it's a little, again, it's not set in stone, but we do use those guidelines to the best of our abilities. And as those things come to the surface, like in our shoulder seasons being those Octobers, Novembers, where it's very warm during the day, very cold at night, and maybe April, May, even into March, where it's, again, very warm during the day and cold at night. Those are those shoulder seasons, and that's when we typically see the variety of students kind of complaining about heat or air conditioning in those cases. So with that being said, again, 4-pipe systems are easy. Corbin, Olson, and Grody, they can use their thermostats at any time. It's all digital thermostated, so they can control that. They can call for cool air at any time because it's 4 pipes. So there's always water pumping through, and there's always cold air and heat. They can just call upon it just like a typical home would. In all the other buildings, it's a little more difficult. A common misconception for folks in Lincoln, Washington, and Bayless-Henninger is that their fan coil units control temperature, that it's blowing out hot air or cool air, and they can control that. That's true to some extent. They can control it because it's controlled by a fan coil unit. And so the blower on it is a low, medium, high. All that does is just turn on the fan. So if it's 70-degree air that's being pushed through the building, that's what the fan's going to kick out. It's not going to get any warmer or any colder, but that's a common misconception. The other buildings, we have what's called inductive units. That's at Thompson Hall and Tanner Hall, and those are a little different. And so because of that, we have a little different system. So in Lincoln, Washington, Bayless-Henninger, Tanner, and Thompson, we have a procedure that's kind of a weird procedure, but it makes sense. And again, we want to make sure that when we do report a problem, that the trades are getting the right information, they know if they need extra parts, and they know what they're responding to in terms of priority. Heat and temperature in general is a very hard thing to gauge. What's hot and cold to you is very different than what's hot and cold to me. And so because of that, we have to put these procedures in place. And it's simple. It sounds a little unorthodox, but all we do is if the student comes to you and says it's too hot or too cold in the room, we would ask you to, again, if it's in Corbin, Olson, or in Grody, they would just read the thermostat to us, and that's what the temperature would be. In all the other buildings, they would go to the front desk and get a thermometer. Not all of them look like this, but very similar. And we'd ask them to come into a room and take 3 temperature readings. Kind of one in here in the first part of the room, one in the center part of the room, and then one up to the upper front part of the room by the windows or by the metal wall or the front part of that room there. Once they get those 3 measurements, they then go down and report that back to the desk. That desk person would report that to the clerk, and the clerk has a gauge, kind of a barometer of where those temperatures fall in line. Typically between 68 and 78 is kind of that optimal range. So there's not a lot we can do for them, but we will take that into consideration, and we'll look at the priorities of that. If it's too hot or too cold, that's also on that level of gauge, and the clerk will either put a work order in for a medium to low priority, and if it's a really big problem, if they've got a 90-degree temperature room, that's a little hot, they will call that in. That would be considered an emergency on that part. So that's kind of how the heating and cooling is spread and how it's determined. Things we can do to try to keep the air circulating is keeping doors open, which is also good for your community, right? But also putting fans in the room, opening those windows when you can. But then when it's really humid, closing those windows. And it's just common sense type of things like that. That if they can do that, your residents will have it all matters, and it'll help build a better, comfortable community up on the floors.